Good morning and a warm welcome to the European Imaging Academy webinar series. My name is Stefan Hahn. I'm Portfolio Manager and your moderator today. As most of you are already familiar with STEMA Imaging, I would like to give you a brief overview of the company. STEMA Imaging is a leading international supplier of machine vision technology for over 30 years. The company was founded in 1987 and has been listed on the stock exchange since 2018. We are represented by 20 offices in Europe, Latin America, and Asia. With around 360 employees, we achieved a turnover of 105 million euros in the last financial year. One of the company divisions is the European Imaging Academy, which I would like to introduce to you briefly. The European Imaging Academy offers practice-oriented training courses on a wide range of vision topics. We offer our training courses as face-to-face events in our training center in Puchheim near Munich. In our subsidiaries are also at your site, and during these times of travel restrictions, all training courses can, of course, also be held virtually. Our lecturers are experienced experts from the field, and I would like to hand over now to Christian Eckstein from MVTec, who will be our speaker today. MVTec from Munich is a long time and very important partner for STEMA Imaging regarding machine vision software, and we are very happy to be able to illustrate this special partnership with events like today. You're welcome to post any questions that may arise using the chat function. We will answer those at the end of the sessions, of course, and have fun. So, Christian, the stage is yours. Have fun with the deep learning spectrum from easy to use to full customization with the MVTec product portfolio. Thank you.
Yes, thank you, Stefan. Thank you very much. And thank you very much for having me. So it's really great to be able to partner up with STEMA and to participate in these events. And I'm really amazed by the number of people that are joining us right now. So I'm just reading through the names. I don't know quite how many, but it's a lot. So that's really great. It really shows me how much interest there is in this topic. So I really hope this is going to be worth your while. So this talk will be structured into two parts. So the first one will be focused on, first of all, how MVTec wants to approach deep learning, how we want to tackle this very quickly developing technology. And then I will talk about our product portfolio. So I will talk about all three products that we have, and those are Halcon, of course, the main workhorse product that we have. And then there's also the deep learning tool and Merlic. And I will talk about the integration of those three tools and how to very easily achieve a deep learning solution. And also especially how you can approach it differently from just an easy to use, very user-friendly application to full customization and whatever you need to do. So Stefan already introduced me, but again, let me hide this. Sorry. So my name is Christian, and I'm here in the role of product manager of the deep learning tool. So this means that there will be a focus kind of on the deep learning tool, because this is what I know, and I will also show you the tool in action. So this is not just going to be slides. We're actually going to do a training of a deep learning network. And then you can see how easy that can be done and how you can do it yourself this afternoon if you're free. So do you know the movie The Irishman by Martin Scorsese. So this movie is a 2019 or 2020, I think, Netflix production, and was supposed to be this great last movie of this of Martin Scorsese, this iconic director, and he casted his old boys basically. So the movie Irishman is about the life story of two gangsters played by Robert De Niro and Joe Pesci. So and you can see them on the screen. But the only problem was it was supposed to be about a life story. So he had, and the actors are in their 70s right now. So he had to shave off about 40 years of age for the movie. So how did he do it? He approached the best visual effects artists in the world, and those are Industrial Light and Magic in California. And I think they were founded for the Star Wars movies in the 70s, and they've won, I think, the most special effects Oscars ever. So they are the top people when it comes to special effects. So, and the task was to shave off 40 years of those actors. And what they did, you can see on the screen right now. So they had a main camera for the filming, and then two additional cameras. So two additional just black and white cameras for stereo imaging. And they did a whole 3D reconstruction of their faces, and then remodeled the faces after younger versions from younger movies. So this took about 4 years to do. So they had, by hand basically, remodeled each facial expression of these actors to try to make them younger. And this took 4 years and millions of dollars of investment. And if you see the movie, so you can watch it on Netflix right now, it's not really convincing. It does look kind of fake. It does look kind of strange. The faces are moving strangely. They are shifting. And the actors also don't look as young as they should. So it's not quite 40 years. There's a 70-year-old man playing a 30-year-old man, and it doesn't quite work. So in 2020, there was this guy. He used deep learning, and he trained a gun model on just old movies of those actors, and then posted them on top of the actual scenes. And you can look at it yourself. You can look at YouTube and try to find this. It's quite amazing how just some guy at home using deep learning could do something, excuse me, that took others millions of dollars of investment and years of development. And I think the results are quite convincing. And what this example shows me is how rapidly deep learning is developing. So this was just last year, and there is a new de-aging model coming out now, and also Industrial Light and Magic, so the special effects companies, are using deep learning now as well for this. So how do we, as machine imaging experts, navigate this landscape of rapidly evolving technology? How do we pick the right kind of technology that solves our problems best? And I want to show you a model that we at MVTec developed to approach this. So this is a very high-level view of the values of deep learning and how we think about it. So we have those three pillars that we try to focus on. So the first pillar is holism. So we think we have to approach, we have to have a holistic approach of deep learning. So that means we have to supply software for the entire value chain. So from data management to labeling, to training, to model evaluation, and to deployment. But also beyond that, camera integration and process integration has to be just from one software vendor. It's just too complicated to pick and choose all the time. The second is diffusion that we really believe in. So that means that we want deep learning to be accessible and very easily applied to industrial machine vision. So that means that we have to focus on usability. So we have to make it available to everyone. But we also have to pick the right technologies that make sense. So, for example, I talked about GANs, those generative adversarial networks. They are not going to be any use to us in machine vision for industrial applications. There are some approaches for certain synthetic imaging to use for training, but there are a lot of reasons why this doesn't make sense. So we as a software provider have to pick and choose for our customers. And we also have to train these networks on industrial images. So there are a lot of networks out there on the internet for classification, which are great at identifying cats and dogs, but not defects. And the last one is integrity that we try to focus on. So that means that we want to provide the full solution with no dependencies, so you don't have to install anything else, as you a lot of times have to do with open source software. And we also want to focus on integrity in that we train our networks on data that does not infringe on anyone's rights, which is not a given. There's a lot of networks floating around where this is a very big gray area, whether this is legal. So with MVTec, you're absolutely sure that what you use is legal. And we also want to build trust in deep learning. And trust means that we want to invest in technology that opens the black box and helps to understand why this network made a decision, which is in many industries a problem still for deep learning. So this was pretty abstract, so let me break this down for my product, what that means. So my product is the deep learning tool. Well, what it does I will show you later, but what does those three pillars mean for this product? So integrity, for example, means that we want to have our customers control the data. That means we do not force anyone to upload the data in any cloud for training. It also means that the product has to actively help to improve the data quality, and improve the model quality in the end. So there are a lot of, so we're building in a lot of active support features that detect falsely labeled images, for example, or help automate certain training strategies. This is something that is pretty close to release, that we're putting a lot of research in. Diffusion, of course, for the deep learning tool means great usability. So with a deep learning tool, you can train a model without the need for programming anything. So no line of code required. I will show you this shortly. And holism also means the tool has to support the full life cycle. So from labeling to training and model evaluation, everything has to be in one tool. It also means, holism means that it has to seamlessly integrate into our product portfolio. And this integration and the interplay of the different products is one of the key features of this talk. So let's dive right into this. So how does integration between Halcyon and the deep learning tool work? So if you want to do deep learning with MVTec products, you can just use Halcyon for the entire way. So you can use Halcyon, of course, for image acquisition. Halcyon provides all the necessary camera interfaces. You can do pre-processing. So a lot of deep learning approaches require some pre-processing, especially anomaly detection. We require a lot of pre-processing. So this can be greatly done in Halcyon. And then you can skip over to the deep learning tool. So management and labeling is best done in the deep learning tool. So this really focuses on the usability of this. So the deep learning tool also is a free product. So imagine you have one Halcyon SDK for the developer, and then you have, let's say, 10 students labeling data. So we know that for deep learning, a lot of effort is put into just data management and labeling. It can be up to 80–90%. So just cleaning out the data, image generation and classification and labeling. So the idea is that the deep learning tool is free, and you can distribute among, let's say, 10 people for labeling, which is great. And then for training and evaluation, you can choose. You can either do it in the deep learning tool, or this would not require any coding, or you can do it in Halcyon. And this is especially interesting if you want to do some automation. So if there's additional pre-processing after labeling, and if you don't want to do training automation, so you want to try different training strategies, let's say 10, 20 different strategies, and just have it train on a server, and that will be best done with Halcyon. And for the deep learning tool, you can just do it for easy evaluation. So can I solve this problem with deep learning? You can just evaluate that very quickly in the deep learning tool. And this we will look at right now. So how can I just very quickly solve a simple application? Let me just switch over to the deep learning tool. I hope the resolution is fine for you, but if you just make it full screen, it should be. So this is a completely blank tool, so we will start from scratch. I will create a new project. We will just do a classification project. So just a background. Classification assigns images to classes. So this can be just 2 classes, good and defect, for industrial machine vision, which makes sense. Let's call this project Deep Learning Spectrum and create the new project. So there we go. That's it. So the project is created. What we will need now is images, of course. So let's import some images. And just for convenience sake, we will import an entire folder. So I have this subfolder, Deep Learning Spectrum Images, and I will add this entire folder. So one great thing about the deep learning tool is that the images have already been subdivided into folders that already correspond to classes. So we have the contamination class, the crack class, the good class, and the unlabeled class. So the images were in folders, so we don't have to label them all right now. So we can see there's just 9 unlabeled images, but the rest was already pre-labeled. So let's import the data and label the images. So that's it. This is all the images. So I should talk about what is the idea of this project. So the idea here is to find defects in pills. So this is a real life application. We have a customer that we completed this project with. So there's 3 different kinds of defects. There's contaminations. This might be those little specks in the images. There are cracks. So a crack, there might be a whole a chip in the pill, and there are good images. Sorry about the background noises. There's some construction going on in the background. I hope it's not going to be too bad. So let's jump to the review tab because we had some unlabeled ones. Let's just go through them. So there is one. So let's just select the ones with the contamination. We'll just assign them to a class. Now there are some cracks, as you can see. Let me just enlarge this. So this is a crack. This is something chipped away from this. So let me select those images and assign them to the cracked class. Oh, sorry. Assign them crack, and then the 3 good images left. There, I don't see any defects. So now we see the unlabeled class is empty, and I think we can just probably delete it now. It's not going to be required anymore. So that's it. So This can be a lot of work. We have about 1,000 images now. There can be projects with a lot more, 50,000, 100,000 images. Depends on the project. So then the next step would be to create a split. So split for deep learning means we have to separate the images that we have between training images, validation images, and test images. So the training images are going to be used for training the neural network, and each generation is going to be validated against this validation image set. And then it's going to improve on itself until it basically masters the validation set. And then in the end, for evaluation of the model, we will test the model against the test images. So I can play around with this, but if I have a lot of images, I'm not going to require so many test images. I can just use more for training, but the default is fine for us right now. So I will create this split and apply this distribution. So what the deep learning tool shows you right now is the distribution of the classes between the different data sets. So this really helps you find a problem if some classes are not really represented in a split. So if there is, let's say, validation split with almost no images from one class, it's not going to work. So you can see if you have a proper distribution. Well, in this case, we have equal amounts of contaminations, cracks, and good images. This is not going to be the case in many real-world problems where there might be very rare defects that you still want to be able to detect. So you have to make sure that they are distributed evenly. Right. I think the split is fine. So let's start training. So as I said, the deep learning tool is free. So all of you can, after this talk or this afternoon or tonight, while you're watching The Irishman, you can log into your MVTec account or create one and download the deep learning tool and can try this for yourself on any images that you have. You can also, just with your phone, take some images of, let's say, coins, and then try to classify coins, just to familiarize yourself with deep learning. And if you don't have a very strong background, we have integrated the help to the right in the tool, so you don't even have to look anything up. It's all going to be in one screen. So now that we have a split, we're going to start training. What's the problem? No split selected. All right, I have to create a new model. For this, I have to save once. And I will just create the split that we just created. So what I can do here is select the deep learning parameters. So those are, I can select the model type. So there's compact, enhanced, ResNet, and so on. So different model architectures. For us, just the compact is fine for now. And here are the pre-processing parameters. It's just the number of channels and the image size, and we're just going to work with the default parameters here. I can also select the device I'm going to be running on. So I'm just going to do this on this little i7 CPU. I'm just going to do the training on the CPU. It's not great, but it has to be enough for us. And here I can also select the training strategy. And we're just going to work with the default parameters now, and they should serve us well. Right. So this is basically configured. It didn't change anything, but well, that's fine. I'm going to start the training now. So during the training, what the model wants to do, it wants to minimize the loss of this function. So it wants to minimize the error against the validation set. So this curve is going to come down just by the number of epochs. So this is going to be 20 epochs, so 20 generations of this network. And it says it's going to take, so this training for classification is going to take around 7 minutes. So while we are waiting for this, let's switch over to the PowerPoint again and just have it train in the background. So I want to take a look into the future. That means I want to show you the what we have in store now for the deep learning tool, because this is my product. This is what I know best. First of all, I want to give you another overview of the deep learning technologies that are supported by MVTec. I'm not sure if you're very familiar with everything. So just to recap for the professionals out there. So the first method is edge detection. So this is quite new. I think this is 2011. So this is end of last year in Halcon. And this is specialized in detecting edges in images. And it can detect edges in images with ridiculously low contrast. It's really great. So you can see, I will show you this later. This example again, the contrast is really low. And this is just specialized in finding those edges. It can be pre-trained or it can just be used out of the box. If you want to do something like this, like just finding the edges between the wood panels and not the wood strains themselves, you're going to have to train it. It's not going to work out of the box. It's going to find all those edges, but you can train it and then it's going to work very well. So this is edge extraction based on deep learning. The next one is anomaly detection. Anomaly detection is really great because it's an unsupervised deep learning method. So that means it does not require you to label a lot of images. It just uses good images and then finds anomalies in those images. So you just give it, and it also requires very few images. So you can work from 20 up about 100 images. This is going to be enough. And if there is anything diverging from the images that you fed in training, this is going to give you a false class. Then there is segmentation. So segmentation classifies not images as does classification and anomaly detection. Well, that's not true. Classification classifies images. Anomaly detection classifies pixels, actually. So it says this is those are normal pixels, and those are abnormal or anormal pixels. And the same is true for segmentation. So segmentation assigns each pixel in an image to a class. So that means we can. So these are vegetables. We know exactly which pixel represents which kind of vegetable. And this is extremely labeling intensive because you have to label pixel-wise. So you need a big training set, a big data set, and someone has to paint all the pixels. And this is really holding back the diffusion of this technology, the vast amount of effort that has to put in there. And I'm going to talk about something that we believe will really speed up the labeling process for segmentation. So the next one is object detection. And object detection just finds objects in an image of different classes. So here we are detecting different kinds of screws. So we will see later in the talk real-life examples that our customers managed to solve with deep learning. And we're going to look at a lot of those technologies. So now let's move to the products. So what this tries to show you is the coverage of each product with of each technology with each product. So you can see Halcon. So Halcon is the orange, is represented by the orange color. Halcon covers all so the entire workflow from management to evaluation for all the technologies, especially classification, object detection, and segmentation. And my product, the deep learning tool, is not quite as evolved right now. But it will be soon. So right now we cover classification until training and evaluation that we just looked at, and labeling for object detection. Right now we are developing segmentation. This will be released in, I think, on the 22nd of July. So about a month from now, you will be able to label segmentation. And then later this year, we will pull this the whole way down for object detection and segmentation. So we'll also be able to train in both products. Before I talked about segmentation, that segmentation is really problematic because the labeling effort is so big. And with the release of segmentation labeling in the deep learning tool, we will also release some technology that should really reduce the amount of manual labeling required. So here you can see two examples of one method. So we call this interactive segmentation. So this method that you can see, I hope the GIF works for you. You can see what's happening on the screen. You just need 4 clicks on the extremes of the objects, and then 1 click outside of the object, and then it segments the object automatically. So this really reduces it from painting the edges down to just 4 clicks. There are other methods that we are doing research on. So we found out that one method is not going to be enough for all different applications that you have out there. So we will implement several applications. So this is a different one. Here you click inside the object just with a left click, and outside the object with a right click, and then it manages to segment the objects quite well. So you will see for the right object, it's not perfect. It's not perfect pixel-wise, but a lot of times that's really not required. You don't have to. Well, depends on the application, of course, but a lot of times an approximation of the pixel area is enough. Right. So evaluation in the deep learning tool. So I hope this gave you a short look into the roadmap. What will be coming next for my product, at least. So now let's look back at the deep learning tool and back at the training. So it did complete. So I managed to talk for about 7 minutes. Right away, we can see the validation accuracy. So this is not on the test image set, but on the validation set. It's 99.3%, so we have some errors. But let's look at the evaluation. So to do an evaluation, we select the model. So this is just what we trained. We select the image set that we want to test it against. This is just going to be the test image set that we defined earlier. And then we run this evaluation. So it takes a few seconds, and we can see, well, the 99.3% are the same for this data set. So we have 1 false prediction. So there was 1 error made against those 143 images. It was also very nice. As you can see here, you can see the inference time on the hardware that I'm running this. So this is we first gonna have to do some pre-processing. So this is basically just scaling down the images, scaling down the image resolution. This takes about 1.29 milliseconds, and then the inference will be 4.36 on the hardware that I'm using. And this is just my shitty 2-core i7 CPU. So this is not even a dedicated NVIDIA GPU that is specialized in inference of deep learning. So I can write a comment. So this is pretty good first try. This is not even with any tweaking or trying to improve the model. And down here we can see a class overview. So where exactly are the errors? So we have 1 false positive in a good class. So this was classified as good, but it shouldn't have been. But let's have a look at this image. So for this, we can use the interactive confusion matrix. So this is, I hope this is not too small. This is just a 3-class example there. It can be much bigger if you have more classes. So that's the reason why it's so small. So here we can skip through the different classes. So this was predicted as a contamination, and it is actually, so the ground truth is also a contamination. So this is correctly classified. Let me just enlarge this. So here you can see the contamination, and it classified it correctly. So we only have images with contamination. Same for the cracks. So here is some kind of crack, different kind of crack on the side, and a crack here. There is one false prediction. So here the ground truth had been cracked, but it was predicted as good. So for some reason, the crack down there was not detected correctly. To help figure out why, something that can help is to enable the heat map. So having the heat map, the format changed because of the preprocessing. But the heat map shows you the area of pixels that were most relevant for making the decision. So you can see it is around the crack, and this is what we would expect. So sorry, around this contamination. This a little bit bigger. So this is what we would expect. Hopefully this is the same for the crack class. Yeah, so you can see around the crack is also the area where the model saw the pixels for the decision. Let's look at this incorrect image. So it does not see the crack at all in this case. I mean, it is small, and it is also very much on the edge, but it should actually detect it. So what we could do here is just use a different model. So we just use the compact model, which is not the most powerful. It's very fast, but it's not very powerful. Yeah, so we have to try to figure out how to improve this. It just sees nothing wrong. Okay, but for a lot of applications, 99.3% would be fine. So, oops, let me move back to the presentation. So what we did right now is train a deep learning model in the deep learning tool. So what I could very easily do is just export the model. This is just 2 clicks, exporting the model, and then for inference, as you can see here, you have to load it into one of our other products. So that would be Halkan or Merlik, which I will be talking about after Halkan. So this is how our concept of those 3 products work with deep learning. So they support each other. So deep learning tool serves Halkan in labeling and also training, if you prefer. So let's have a look at Halkan. So this is just a screenshot, and we will talk through this. So I think for the Halkan professionals, this is going to be quite obvious, and for someone who has never seen anything in Halkan before, this is going to be strange, or not very intuitive at least. So let me try to very quickly show you how you would do an inference of a pre-trained deep learning model in Halkan. So it's very simple. It's just those a few lines of code. So first of all, what we need the model. So this is what we just trained and what we exported. So we just select the path to our export. So this is this model HDL file. We also need the pre-processing parameters. So this is basically the number of color channels and the image resolution, which was modified before training, because usually we don't train and execute deep learning on the native resolution of the cameras. We usually scale it down because it's not really required. So high resolution does not really help. Of course, depends on the size of the objects that we're looking at, but usually low resolution than the humans would prefer is, and the traditional machine vision algorithms require, is enough. So this is all the pre-processing parameters. We have to load them, and then we also need the path for our images for inference. Then we will read this data. So we read the model. This is just one line of code. Read DL model, and then we enter the path that we created before, and then we also read the pre-processing parameters with the path that we created before. We have, for inference, we have to set some parameters, but this is just 2. They are minimum, which is the batch size. Batch size 1 means we're just reading one image after another, so not several at the same time. And we also require a hardware for the runtime. So in this case, it would be the GPU. I trained and executed on this on the CPU, which works very well with Halcyon because it's quite optimized for the CPU. But GPU is faster, of course, in any case. So we configure this, and then it's just a case for a simple for loop, which reads an image from the location that we specified before. It loads the pre-processing parameters and applies the pre-processing to the image, then applies the model, and then gets the result and then displays the result. So that's it. It's just a few lines of code. And here we see the results. So in this case, this would be classified as a crack, this image. So here you can imagine how you can use first a deep learning tool for labeling, a free tool. You can give it to 10 people. They are labeling. And then you train probably on one server or on one dedicated training machine. And then you will probably use Halcyon or Merlic for deployment, because Halcyon also and Merlic both also offer the full camera integration on the one end and also the help you during process integration on the other end. Right. So I alluded to this. You can also use this with Merlic. So what is Merlic? For those that are not familiar, this is another tool of MVTec. It is this all-in-one solution. So for Merlic, no programming is required as well. So you can just drag in tools, connect them, connect inputs, connect outputs, and then get your results. And by the end of this year, Merlic will also be able to perform deep learning. So it is this one all-in-one product. It also helps you very easily design a front end. It has all the camera interfaces and a lot of process integration functionality. It's very powerful. It does not only do deep learning, it does also do very basic, well, not only very basic, but actually very powerful traditional machine vision. So there are a lot of tools if you want to do an alignment, a camera calibration first, and whatever you want to do. If you want to do detection, object detection, and then read a code or read some text, it's all in the tool. And it's super easy to use, as I said. So it does not require any programming. So let's think this workflow now in terms of Merlic. So how would I approach deep learning project with Merlic? So I would probably do the image acquisition in Merlic, and then do also the pre-processing in Merlic, because Merlic has all the tools that you would need for that. Then you would do the management and labeling in the deep learning tool, and then do the training and evaluation as well, of course. And then the inference again in Merlic. Right, so, and this inference feature will be coming this year. It will be in autumn, I don't know, around October, November. Let's see. This should be announced quite soon, I think, the release date of this. So what will Merlic be able to do? It will be able to do, in addition to the interaction with the deep learning tool, it will be able to do anomaly detection. So for anomaly detection, so this is the one where you don't need bad classes, you just need good images and it finds anomalies. You can do the whole process in Merlic. So here we don't really need the deep learning tool because there's not a lot of labeling you have to do. You just need a few bad images for evaluation and not any for training. So you can do the image acquisition, the pre-processing, this little bit of labeling that you need to do, the training and the integration all in Merlic. And this is really a great feature for easy to use if you just want to find anomalies. No label, so very little labeling required, and just find anything that's wrong with the image. Right, so this also will be coming this year. So what will it have, the Autumn 21 release? So this will be Merlic 5.0. It will have anomaly detection. It will have deep learning classification together with a deep learning tool. It will also have deep OCR. Deep OCR is, so this is not, well, this is deep learning based. It is definitely deep learning, but it is not in the deep learning package in Helken, also not in Merlic. So it's basically going to replace a lot of traditional OCR applications that we have. And it's amazingly powerful. So you can just point it at text and it will read it. I think we did a benchmark. This is, I think, the best OCR out there right now, at least. At least for no additional training, so you can just use it out of the box for text, and it works really well. So this is definitely world-class right now, the deep OCR. So now we have the whole picture. So this is the MVTec product portfolio. We have Helken up there, which is this big machine vision library, a lot of traditional machine vision algorithms, and all the learning algorithms as well. And you see the deep learning tool in the middle, which is just for labeling and management and training and evaluation of deep learning models. And then Merlic at the bottom, which is just this easy to use, no programming required approach. Right, so this concludes the first part of my talk. So we have about 10 minutes left. So what I would like to do now is look at some real-world applications of deep learning, which should be interesting to you. So there you can see what variety of problems deep learning can solve, and how those different methods that I talked about, so the classification, segmentation, and so on, what kind of problems they can solve. I hope that provides value to you. It also shows you how many images you would need. Right. So let's look at some classification examples. So this is one of the first projects that we had. So I have to say this is just a selection of very few problems that I found interesting, and they are very different. So it's a big variety. It's not just your typical industrial looking for a scratch or a defect. It should show this huge variety of problems that you can solve with deep learning. So just a few examples. Our partners, Stemmer, for example, or in Feynman, we know that they have solved super interesting, super complex problems with deep learning, and with their partners as well. So this is just a look into this world. So the first example that I wanted to talk about is identification of plants. So this customer, they wanted to, it's not only, so one of the products was identifying fruit. So where are fruits? So which images contain fruit and which don't? But it was also just about classifying a plant. So it was a big agricultural company. You can point your phone at a plant. Maybe you're aware there are several kinds of apps that can do that. And then it would suggest the right fertilizers, for example. So their problem that they had, their challenge was that they had to manually program each different kind of plant, and they had to do that separately by country, and that was a lot of effort. So the challenge was to just reduce the amount of programming required by a lot, and that worked. So the error rate, just with deep learning, worked very well. So we halved about the amount of errors. There's still a 10% top-free error, but for this kind of application, it was fine. You can imagine how many plants are out there and how divergent they can be. But this is also one of the strengths of deep learning, identifying amorphous objects. So let's say like bakery or plants, just objects that look different every time you have one. And deep learning is very good at separating also those intrinsic evaluations of quality. So let's say we have a bakery, and there's someone has to decide when is it burned, the bread, and when is it fine. A little bit of burning is fine, and then you can just have the baker label images. Those are good, those are bad, and then the deep learning model will be able to separate those. And for those cases, error rates of 10% are fine. The next case is identifying empty shelf slots. So not sure if you can see empty shelf slots. So they would be around here. The main problem for them was they had a solution working, but it was really expensive. It was a very complex 3D solution, and they wanted to just save costs by switching to cheaper 2D hardware. And this actually, a lot of times, is a typical application of our customers. They want to save money on hardware. They want to switch from 3D to 2D, and deep learning can help there. Also, the error rate dropped significantly. So from 2.56%, we went down to 0.29%. So this worked really well, identifying those empty shelf slots. The next case is the one that we basically did just now, is classifying defects in pills. Yeah, I think don't really have to talk about this too much. So they also had the problem that they had to manually program the classes, and the main problem was that new classes they had to add, and by adding just the images of new defects really helped them. So you just add the new classes, add the new image, and then retrain the model, and that saved them a lot of development time and costs. So there are some more examples. It can be from plants to pills to nuts to ham, circuit board, of course, as well. But you can see a lot of those examples are amorphous objects. So objects that can do that can look different every time. So plants and ham and nuts, they are natural products, but it does not have to be. It can also be just your classic defect detection in production of metal parts or plastic parts. So now let's look at object detection. So here we want to detect an object. So we draw a rectangle around the object and we want to find the position. So those can be just those bounding boxes, but it can also be oriented rectangles, which also show the alignment of the object. So here we had a very interesting case. They wanted to they had images of pallets of newspapers and wanted to find out how many newspapers or how many packs are on each pallet. And the problem was that the height is undefined, so that it can be big packs or small packs. And also it was almost impossible to find the transitions where one pack ended and where the next one started. So so the idea was, well, let's find those wraps around the packs and then just count them. So we use object detection to find those wraps. And also, what is I think very interesting to note is this solution did not only require deep learning, it also required some traditional machine vision. And this is quite typical. So usually just using deep learning is not going to be enough. So here, the first step was deep learning classification. And then from there, they had to weed out a lot of false positives using just traditional blob analysis, and this really improved the result. So the combination between deep learning and traditional machine vision is really powerful. So, well, they had around 1,500 images, well, which is not so little, and a lot of papers, 15,000. And the positive rate was then 95.8%, which is, for them, is probably fine. So if there's in every 20 there's one too many or one too few packets, that is tolerable for them. The next one is quite interesting because it's a combination of two methods. So the idea is there's a robot roaming those shelves and they want to find empty slots. So we don't have any prior knowledge about where the product might be. That was the problem, just the image. And the idea was, well, then let's use the labels, which which help us find the shelf, because shelves can be very big and very small. So just let's use the labels. So we first did an object detection to find these labels. And then we know, okay, the object should be above the label. And then we use the classification above the label to classify whether it's empty or not. So you can see empty or not shelves. And this worked really well. So this was just done with 365 images for the detection step, and then some more for the classification. Well, because there's a lot of labels in one image. So this worked really well just with a few images, just with a few hundred. And then a very typical case, counting people, which is always not easy, but a very typical object detection application for demos, I would say. Yeah, but here it's very challenging because the light changes, the object change. People can be bringing in all kinds of objects, and deep learning is really powerful there. And the next one is just a very typical application, just doing presence check, is the object there or not, and counting. So here it can also be done with very low contrast and very unstructured reflections that work very well. So this is a 99.1% true positive rate with just, well, with about 800 images, not quite. Then some examples. So I have 3 minutes to go. Well, let me show you at least one or two for semantic segmentation. So here we want to segment the defect out, so the actual individual pixels. So this is the same example of the pills. This is actually what one of our customers uses it for. The problem was there was a lot of different pill types, and they wanted to measure the size of the error as well. So segment out those pixels. And this was really a big project, a lot of images, 50,000 images, and they had to be labeled by hand. I think, yeah, this was done by an external company that the labeling, but there are a lot of companies out there that can perform this. Yeah, you can do it with plants, which is fun, and just traditional plastic parts, finding defects, finding scratches, and especially segmenting out the area and the size to make your decision on whether this is passable or not. Tires is also very challenging because the structures, the OK structures, look very similar to the not OK structures. And they had this huge line scan images, and the contrast is very low. So you're basically looking for black on black. This also worked very well. For anomaly detection, I did not find, I have not prepared. There are some. I should prepare some slides for this as well. But here are some typical examples. Those are not actual custom examples. Those are just some MVTec internal examples. So we were looking on the left at bottlenecks that are damaged. Then there's some. This is food. This is Japanese food, and there is some objects in there that should not be there. Anomalies on pills again, on fabrics and continuous materials. This really works very well. And also food products in just metal parts. And now again to this edge extraction. And now I just wanted to show you how well edge extraction works with very low contrast images of a blurred or strange background. So this really helps you. So this would just be a tool where you use deep learning just as one step to find edges, and then you would continue with traditional machine vision algorithms in Halcon. Yes, and yeah, this is just to show you again the power of the edge extraction. So this concludes my talk. So I hope I have given you an overview of what methods we support, how the 3 products interact. So you have this huge library, full customization in Halcon. You have a very easy to use tool in the deep learning tool that helps you labeling and training, and that is free, and that you can distribute in the company to put this task of image labeling on as many shoulders as you can. And then there's Merlic, which will support by the end of the year also 3 deep learning methods, and which is super easy to use and is enough for a lot of applications out there, and which should save time on the whole project. Right. So this concludes my talk. So thank you very much for your attention. I hope this gave you an overview, and yeah, I'm looking forward to your questions.
Thank you, Christian, for this very interesting presentation. Now we can start with the questions. We have received a number of questions. Some of them were certainly answered during the presentation. Christian, one of them is, can Halcon study with deep learning do instance segmentation, and can we use deep learning tool for segmentic segmentation, labeling, and training?
Right. So this touches on instance segmentation. So instance segmentation is similar to semantic segmentation, but in addition, you can separate different instances in that. So it's just, so let's say you have an image of, let's say, 10 cabbages, and you don't want to just know where is cabbage and where is not cabbage. You really want to differentiate the different cabbages in the image. So there you would use instance segmentation. Instance segmentation will be included in the upcoming Halcon release by the end of the year. So this will be 21.11. It should come out in November. And yes, we are trying our best. No, I'm pretty confident it should work, so that during the release of Halcon by the end of the year, the deep learning tool will be able to support instance segmentation for Halcon. Okay. Yes. So the answer is yes.
Yes.
I'm hoping I'm not leaning too much out of the window, but if we don't manage it, it should be just a few weeks later. But there's a lot to do. But yes, this is definitely our goal.
Okay, thank you. Another question is, what deep learning method do you use for the classification?
I'm not really sure if I understand the question correctly. So, well, in our terminology, classification would be a method. So there are, for classification, I'm not sure, maybe this answers the question, there are different network architectures that can perform the same task of classification. And we support, I think, 5 different network topologies. So they range from very compact, very small networks, which take very fast to train and which can run on embedded hardware, up to very complex, very big networks, which require a big GPU. Yeah, so I hope this answers the question.
I think so. Yes. Thank you. One more question is, can the Halcon deep learning tool only be used for classification tasks, or also for other tasks like segmentation or edge extraction?
Right. So the deep learning tool right now, so as we're speaking, if you download it now, it can only do training for classification. But by the end of the year or early next year, it should also be able to do object detection and segmentation.
Okay.
Yeah.
Thank you. We have a little bit time for another question, like, are there plans for adding instance segmentation?
Yeah, I talked about this. So yes, instance segmentation by the end of the year, 2011.
Okay, right.
Sorry, 2111.
Yeah. So yeah, I just have a look to the questions.
Yeah, but it's great to hear some interest in this technology. Yeah, that's great.
Here, on semantic segmentation, your standard network is based on SPSnet, which is kind old. Do you plan to add on any newer architecture soon, like UNet?
Yes, so we are. Yes, we are doing research on this. Of course, yes. I cannot exactly tell you when, but yes, we are doing research on updating the network.
Great. And another question, what are the approximate costs of the presented softwares, Hulk and Merlin deep learning tool? Is Merlin more expensive than Hulk?
Right. So for my product, it's easy. The deep learning tool is free. But for inference, you will have to use either Helken or Merlin. So you will require a license. So for the exact pricing, I would refer you to Stemmer. So just contact them, and they know everything because it's quite complex. It depends on the volume. It depends on the hardware that you're running it embedded. So just contact them, and they can tell you quite quickly if they see your application. And about the question of the price difference, so it's roughly the same, I would say, the Helken and Merlin. So Merlin has some additional features in that you have this front-end designer and you have some more tools for integration. But on the other hand, Helken is much more powerful in terms of the variety of algorithms that you can use. But it's around the same price.
Okay, thank you. One last question. Is it possible to use Hulk and deep learning for surface inspection of patterned objects?
This is very specific. So for patterned objects, you would do probably some traditional machine vision to deal with the patterns and then apply deep learning afterwards. So I can imagine that especially the combination of traditional machine vision and deep learning is very powerful in this case. But it really would depend on the defects. If you have this case, just contact Stemmer. We can do an evaluation of your problem. So those are free, basically. You can just send the images. And we will find out if it works.
Okay, great, thank you. So all unanswered questions will be answered and made available afterwards. Thank you, Christian, for your presentation. So now I have some more info for you. If you need more own know-how, STEM Imaging offers all types of training designed as hands-on training, like learning by doing. Experienced trainers give you practical tips for your own application. And yeah, all current topics and dates can be found on our website in the section Learn. And also, we also support you with feasibility studies to find the right components and the right setup for your application. If necessary, we also establish contacts with machine vision integrators. So now I have to say thank you. Thanks for your participation and attention. We are looking forward to welcome you in one of our training courses or at another webinar. In case of special questions, please get in touch with Lars Fermum directly or with the whole STEMMA team or MVTec. So thank you and have a nice day.
Yes, thank you very much.
Bye.
Bye.